Hello, this is the second part of chapter 4.3, and we will talk about the spanning set theorem. And before we talk about the spanning sets of vectors, and this is just any set of vector which cover all the vector space we need. And it can contain more vectors than we need. For example, here we took a three-dimensional space and we span it with 6 vectors, which is clearly excessive because we know that we can define any points in three-dimensional space with just 3 vectors. So, and these 3 vectors form a basis. So the basis is basically efficient spanning set, is minimum number of vectors needed to cover a given space. So it does not contain any unnecessary vectors. So the question arises how we can convert our spanning set, which might be excessive, to the basis, which is an efficient set. And this is where the spanning set theorem can be really useful, which tell us to go through our vectors in a spanning set one by one, explore each vector and see if it can be expressed in terms of the linear combinations of other vectors. If the answer is yes, we will get rid of this vector and go to the next one. So we end up at the end of this exploration with a linear independent set of vectors which form the basis. For example, let's look at our 3 vectors, v1, v2, and v3, and v4 here, and we will try to find or trim it down to the basis for the vector space spanned by these 4 vectors. Okay, let's start by writing down a matrix of this consisting of 4 columns. Each one is the vector from v1 to v4. And of course, we will try to reduce this matrix to the echelon form. And okay, nice surprise. We have now the 1 row 4 of 0, which is great, but it's also tell us that we have pivot columns only in the first 2 columns. And the other 2 columns can be expressed as the linear combination of the first 2. You can try to do it as a practice. For example, we can write down 2, 1 as a linear combination of first 2 columns and do the same with the fourth one. So we do not need the third and the fourth columns in this matrix for the basis. The v1 and v2 is enough to span the space. Okay, now you can go to the end of the chapter and practice to a little more how to take out excessive combination of vectors in a spanning set and trim it down to the basis.